سلام علیکم. انشالله که حال احوال شما خوب باشه، سلامت باشید. Okay, this is another section of advanced database. In previous session I talked about the replication lag and some challenge and problems which cause because of replication lag. Okay, the replication lag can be solved by application developer or designer of database, but we prefer to the replication lag is solved by designer of database, not by programmer and developer, because I say you that many developers prefer to see database as which store in one machine, not in some machines. Many developers prefer to use the database which have this appropriate methods, appropriate procedure for replication. And the solution which are provided by designer, by a database designer, is better than the solution which are presented by application developer. Okay, now I'm going to talk about another type of replication which is called multi-leader replication. Before talking about this topic, you can download some video file from portal Dasa. I uploaded the video file for 2 sessions in the Dasa portal. Includes some video files about the replication and something that I say in this class. You can download them and you can watch them accurately and find your solution. And if there is another question, you can ask them in next sessions, inshallah. Again, please see the portal, the Dasa website, and download the video file which are uploaded for your course. Okay? Okay. I uploaded the Farsi in Farsi language. You download the Mustafa. You download the file and the language is Farsi. Mustafa Karim, you download the files and the files in the language is Farsi. Okay. Okay, okay. Inshallah, inshallah, I will upload it in English. Okay, thank you, Mustafa. Okay, inshallah, I will upload it in English. Okay, sooner in this week, inshallah. Thank you. Because of your declaration. Thank you. Okay, inshallah, at the end of this week, you can download this some video file in English, inshallah. Okay, now I'm going to talk about the multi-leader replication. Previous one, I talk about the single leader replication. In single leader replication, there is one matching which selected as a leader, and other matchings are selected are called as a follower. And you know, the leader responsible to manage all write requests, and the followers can be used for read query. Okay, another type of replication is called multi-leader replication. Okay, in this technique, there are some leaders. Okay. Also, this type of replication is called the master-master or active-active replication. Yes, in this technique, there are some leaders. Okay, so complexity is high and rarely makes sense to use in a single data center. Okay, but for some type of matchings and systems, the multi-leader can be useful, can be beneficial, especially for complex systems where when data is too high and when we need to use some leaders because of the number of queries, the number of data which are stored. When we have huge data, and when we want to partition the data, okay, so in this type of system, we prefer to use multi-leader application. In this technique, there are multi-data center operation. There are multi-data center. A leader in each data center. Again, there are some data centers, and we can use a leader in each data centers. When there are some data center, please let me to yes, in this figure you can see. There are two data centers in this figure, the data center 1 and data center 2. Each data center has its own leader and its own followers. Okay, so instead of changing information between these two data centers, you know, in the single leader technique, one leader is selected for all matchings. Okay, so when there are some data centers, all matching in all data centers need to send and need to synchronize their data with the single leader. But in this technique can present a better performance in comparison with single leader replication, because the inter data center network delay is hidden in this technique. The inter data center network delay is hidden. because the follower need to each leader send to each leader send the change only to its own followers, and the synchronization can be happen between limited matchings, for example between two leaders, not one leader and all matching which are located in another data center. Another comparison is tolerance, and tolerance of data center outage is better in this technique. Yes, it's you know, it's possible that some data centers outage. Okay, I can say one data center outage, and you know, in this technique, when there are multiple data center, other data centers can continue its running, they're running, but okay, and the only the data center which outage, this data center can repair, and other data center can follow, can continue this its running. And another advantage of using multi-data center is tolerance of network problem. But you can refer to the to some things that I say in previous session. Okay, for example, when one data center is located in Iran and one data center is located in Iraq, you know, okay, it's possible that the network connection between the Iran and Iraq cut off. Okay, and okay, it's not problem because both data centers can continue its running, and without any temporary disconnecting, because they can continue its running, and when the network connection is repaired, okay, is fixed, after that they can synchronize their data. Okay, so these are three comparison between multi-data center operation and using multi-leader, better performance, tolerance of data center outage, and tolerance of network problem. Please attend to this figure again. In this figure, you can see two data centers, 1 and 2. Each data center has its own leader and some followers. Okay, the role of leader and followers is not different from the previous one. Is similar to the single leader replication. We know that the leader is responsible to do read-write queries, and the follower only use for read queries. And we know that write query which is done by leader, the appropriate chains need to send to the follower. But when there are some data centers and there are some leaders, these leaders need to synchronize their data. Okay, and sometimes it must be that there are some conflict between them. Okay, I'm going to talk about this challenge. Again, don't forget that the leader in the data center 2 need to send the information to the leader in the data center 1, and also the leader in data center 1 need to send to the chains to leader in data center 2. But and there is a module that is called conflict resolution. This module is responsible to provide appropriate solution for conflict resolution. Okay, I'm going to talk about this challenge. Okay, I'm going to talk about the conflict resolution. The same data into both data centers, both leaders, I can say, the same data may be concurrently modified in two different data centers, and they must be resolved. And some challenge, auto-incrementing keys, triggers, integrity constraint can be problematic. Some keys in the table can be auto-increment. Auto-incrementing key increasing by inserting new records. Yes, and we know, for example, this in both tables there is, we know that, for example, one table which consists of the which includes students' information is located in data center 1 and another one in data center 2, and concurrently both two records are added to the data center 1 and added to data center 2. We know the ID, or can I say the auto increment key is applied to both records, to these two records, and okay, I can draw something about this problem. This table is one table is located in data center 1 and another is located in data center 2. Okay, I can write the leader 1 and the leader 2. Mustafa asked, is there a difference between the first and second data? Yes, Mustafa. Okay, please let me to write this example. Both leader has some information that is the same as each other. We know that both leader should to have the same information. Okay. For example, A, B, A, and C, B, C. Okay, also we need these data in this table. Okay, these data are the same between the leader 1 and leader 2, and at the same time concurrently one record is added to leader 1 and one record is added to leader 2. The record consists of this information. For example, D, 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 and this one, E, E, for example, E. Okay, and we know that the leader is responsible to send the new records to each other. Okay, so and we know that the first column is auto increment key. So we know when a new record is added to one table, and the auto increment key is determined according to the latest value. Okay, so 3 and 3. Okay, so for these two records, the number 3 is inserted into in this column, and leader 1 and leader 2 send the information to each other. Okay, so leader 1 for leader 2, and leader 2 for leader 1. But we know that this information is not important. Okay, so for example, leader 2 can say triple E these data to the leader 1, and leader 1 can insert this value into this table. And also the leader 1 can send the triple D and this value to the leader 2. and leader 2 can insert this record to its own table, to this table, but unfortunately this value is similar. This is 3, this is 3, and okay, when the leader 1 get the this record from the leader 2, okay, in but the leader 1 is another value for the record 3, because concurrently they receive this request, they receive this insertion request, and so for record 3 different values are inserted into table. But if it's okay, this is can you understand what's the problem? Okay. Okay, thank you. Because we know that when the leader 1 get the triple E from the leader 2, it must insert this value to the table, but you can see that the record number of leader 2 is 3 for triple E, but for in leader 1 is 4, because okay, and there is a difference between these two leaders, and okay, there is a problem. It's a problem. A dangerous territory that should be avoided if possible. Yes, data mismatch, Nazar. Thank you. Dangerous area or dangerous territory, it means sometime, okay, sometimes it's possible that the area is the area is separated into two different area. Okay, if it's possible for us to divide the area into some partitions, we can submit each area to one data center. Okay, so in this state, we can the confliction can be aborted, because each data center can change its own area, and don't and does not change any value of the another area, another territory. Okay, Omar. Again, if it's necessary, I can say again. Okay. Some method for multi-leader application. For example, calendar application on multiple devices. This is one. This is one method for please let me clients with offline operation, collaborating, editing. Okay. One method for these conflict and this conflict I'm going to talk about the conflict resolution. Okay, and one method is one method for conflict resolution is clients with offline operation. The clients can use some operation offline. It means that, for example, the client can each client can use a calendar application on multiple devices. Okay, so they can be different because we know that, for example, I'm using my calendar application on my phone, and in another state I can use my calendar application on, for example, my desktop. Okay, and these calendar application need to present the same activity, the same information, and but we know these they need to synchronize their information. But I can use my calendar application offline, and after sometimes and these application on multiple device can synchronize their data to each other. Okay, I know that some confliction can be occur, but accurate. Okay, I know that, but okay, so in this time, okay, I can use this application offline. Another example is collaborative editing, which is provided by Google Docs. Some users can collaborate with each other for editing. For example, some files can be shared between some users, and okay, we know that this is another example of conflicting. I'm going to say some example for this confliction for this confliction because okay, in this example, this example, another example, these examples are not related to multi-leader, but these are some example which are similar to the multi-leader replication. The challenge is the same between these two application and multi-leader replication. Okay, for example, in collaborative editing, for example, two users utilize the same file. Okay, both users decide to change the file concurrently. Okay, so there are change file, they are going to change file, and okay, this is a confliction because both users change the same file at the same time, and okay, what's happening in this situation? We know different techniques are introduced for this challenge. For example, in collaborative editing in Google Docs, um, create two different files and alert us to that um, uh, both users concurrently send the one files, and these two files are different with each other. And this is one technique that is performed by Google Docs. Okay. We can talk about the handling right conflict in this example. Okay, this example is related to multi-leader replication. Okay, there are two users, user 2 and user 1, user 2, and two leaders, leader 1, leader 2. The user 1 wants to update page with ID 123. Again, please attend to this query. The user 1 wants to update page with ID 123 and set title B for this page. At the same time, user 2 in another data center decide to update page with ID 123, such as user 1, similar to user 1, and set title C for this page. Okay, so both users try to change the title of the same page. In two different data centers. This query is sent to the leader. Leader is responsible to write anything and execute the right query. We know that. Okay, so this query is sent to the leader 2, and leader 2 confirm and send OK to user 2. In this side and another side also, the leader 1 confirm this query, execute this query, and send OK to user 1. Also, the leader should send this information to each other. Okay, so the leader 1 send this query, change ID 123, old value A, new value B, and also leader 2 send the message to leader 1, change ID 123, old value is A and new value is C for the leader 1. First of all, you can see initially there is a page with ID 123, title A. The title is the page 123 has the title A. This is a conflict. And the leader 1 can change because please attend to this message. This message say the old value is A and the new value is C. Yes, the old value is A and the new value is C. But we know that the leader 1 try to find the title of page 123 A, but it cannot find. And so when the leader 1 cannot find the title A for page 123, it cannot change. So it cannot change title from A to C because the title is not A for leader 1 and the title is B for leader 1 because title is now B. The similar conflict is happen in the in the leader 2, because the leader 2 again cannot change from title from A to B, because again the leader 2 see the title which is C, and okay, so it cannot change the title from A to B, because title is now C for leader 2. It's called write conflict. Write conflict caused by two leaders concurrently updating the same record. Updating the same record. Is it clear? Any question? Is a message being sent? Nazar asked, is a message being sent to users of not being synchronized? Nazar, I'm going to talk about the leaders and not users. I'm going to talk about the database and something which happens in databases. The user only send some query for the matchings, and matchings run the queries and send the result for them. Okay, so when the user send a query for the leader 1, the leader 1 only is responsible to execute the query, and if it's possible, it can execute it and send the result, which can be okay or no result for the user 1. Okay, thank you. Handling write conflict. Okay, this is one challenge, write conflict, and now I'm going to handling write conflict. One technique is synchronous conflict detection. Synchronous conflict detection. Okay. We need to detect the synchronous conflict. How we can do that? Wait for the write to be replicated to all replicas. Again, wait for the write to be replicated to all replicas. It means when the write query is sent to the leader, and for example the leader 1, before confirm this query, the leader 1 should send this query, this message to the leader 2. And if there is not conflict, okay, so after that the leader 1 can confirm the query and send okay to user. Okay, so in this technique the user should wait for some moments for each write query. And okay, so in this situation, the performance decrease. The performance of database and for write query can decrease. conflict avoidance. This technique can avoid from conflict. All right for a particular for the particular record go through the same leader. Another technique, yes, for conflict avoidance is to send all right for a particular record go through the same leader. Okay, in this technique the for each in this technique for each record one leader is selected. Okay, so one leader is selected to manage all right for a particular record. Okay, so all right for a particular record go through the same leader. So for example, if the leader 1 is selected for the page with ID 123, if the leader 1 is selected to manage all right for page 123, the user 1 can send its query directly to the leader 1, but the user 2, when the user 2 wants to change the title of page with ID 123, this query is sent to the leader 2, but the leader 2 cannot change the title of this page, and the leader 2 should send this request to the leader 1 because the leader 1 is selected for this record. And okay, so in this technique sometime some user need to wait for some moments because the request must be sent to the special reader indirectly, and this needs more time. This means that Nazar asked, this means that the record can only be changed, the record can only be changed by one leader. Yes, Nazar, yes, sure. Okay, another technique is converging toward a consistent state. In this technique, no defined ordering of rights, and okay, so in the previous slide, neither order is more correct than the order. This is another technique. It means again the order is not defined. And each one can has for example, we know that okay, I'm going to talk more about this technique. Again, I'm going to talk about the converging toward a consistent state. I say you that in this technique, no defined ordering is of the rights, and also in the previous slide, neither order is more correct than the order, because of some reason that I talk about them according to previous techniques. Okay, please let me. We can rest for some minutes for who is the best leader or more than one leader. Mustafa, most previous ones means a conflict avoidance and synchronized conflict detection. Both techniques are not appropriate according to uh, based on this slide, and I'm going to talk say another technique. Okay, so okay, let me. We can rest. We can have a break time for 5 minutes, 5 minutes, 6 minutes. Inshallah. After that, I will talk about to the appropriate technique for handling right conflict. Inshallah, because I'm going to talk about the convergent conflict resolution, which is it's better than previous ones. Thank Okay, Assalamu alaikum. I'm going to talk about one appropriate solution for handling rights conflict. Which is called convergent conflict resolution. You can see 4 methods for convergent conflict resolution. First, give each right a unique ID. This unique ID can be obtained from the timestamp. Okay, from the datetime. From the timestamp is better because according to day, to clock, to minutes, to second and to minutes and seconds, one unique ID can be can be explored, and according to this unique ID, which assigned to each one. Okay, again, the unique ID can be applied to this request and unique ID to this request. According to it can be obtained from the unique time, from the date time. Okay, so these unique IDs, we know that these are different. Okay, so give each right a unique ID and pick the right with the highest ID as a winner. Pick the right with the highest ID as the winner. Okay, so for example, the unique ID is assigned to these requests for each one. And for example, if the user 2 requests this query after the user 1, according to date time, okay, according to timestamp, okay. When the leader 2 send this request to the leader 1, the leader 1 compare the ID, and okay, it can find that the ID of this request is more than the ID which is stored in its own database. Okay, so the leader 1 change the title to C, and okay, so at this state both leaders have the same record. Okay, another technique is the ID specific to the writer or the leader. What is the writer, Nazar? What's the writer? Writer, you means the writer is client. The writer is client. Okay, no, it's usually it's depend to the leader, because you know, the clients or user send the request to the leader, and it doesn't know anything about the leaders and which happen in the leaders. Usually this this unique ID is applied by the leader to each record. Another technique, you're welcome, Nazar. Another technique is give each replica a unique ID. Give each replica a unique ID. And the higher number replica always win the right. Again, higher number replica is always win the right. It means, for example, in this figure, we have two leaders. Okay, we need to assign a unique ID to these two leaders, which specify its priority. For example, the leader one, the one value or I can say okay, please let me to see the okay ID that is enough. Okay. The ID of leader one, for example, ID of leader one is 1. The ID of leader 2 is 2. It's the ID which assign the different ID are assigned to leaders. Okay, so when there is a confliction between the leader 1 and leader 2, always the leader 2 win, because the ID of leader 2 is more than the ID of leader 1. So in this example, the leader 2 send a message to leader 1, and leader 1 should change this conflict and should change the title to for ID for page with ID 123 to C. Okay, so the leader 1 should change its own information at the same as something which are stored in leader 2. Is it clear? Okay. Another technique is merge the value together. Another value is merge the value together. Okay, so in this technique, for page for page with ID 1 to 3, both titles, title B, which is selected by the leader, which is stored in leader 1, and title C, which is stored in the leader 2. Both title must be insert for this page, for page with ID 123. Okay, so instead of B or C, we can see this B dash C. It means that we merge both values for this page. And also, after merge these two values, we can let the application code to decide about which one is display for the page for the users. Okay, it's the application is responsible to decide for which one, for B or C, as the title of page 123. Okay, so in this technique we need to record the conflict and let the application code decide. You get it that handling write conflict and custom conflict resolution logic can be on write or on read. Yes, custom conflict resolution logic can be on write or read. For example, okay, in these three state, the conflict resolution logic is on write, because on write we decide which title should selected for the page 123, because we need to choose the based on the unique ID for each write or unique ID for the replica, or merge the values. Okay, these values, these techniques are used on write. But when the application code is responsible to decide which value is should have to select it, which value selected. Okay, in these techniques, and the application code is responsible to decide, so it's called on read. The conflict resolution logic is on read, because the application code, because the conflict are stored, and we record the conflict, and the application see the conflict and decide about this confliction. Is it clear? Okay. Okay, there are some topologies for multi-leader replication. There are some topologies for multi-leader replication: circular topology, star topology, and all-to-all topology. Yes, in circular topology, you can see for leaders, and when something we change in the leader, for example, in this leader, should send to the next leader. After that, then this leader is responsible to get change from the previous leader, and also add the change which happens by its own, by by itself, and send the change to the next leader. Again, the next leader, after getting the change from the previous one, and add the change which happen on itself, it provides appropriate file, appropriate message, and send the change to the next one. It's called the circular topology. Another topology for multi-leader replication is star topology. In a star topology, one leader is selected as an intermediary between all, leaders. Okay, so other leaders need to change the data, need to exchange. I can say exchange the change which happen on itself with each with the center, with this leader. Okay, so this leader should get all chains from all leaders and prepare appropriate message and send the chains for any leaders. So I can say the load of this leader is more than other leaders because the leader is responsible to get change, and conflict resolution must manage by this leader, and also it's responsible to create appropriate message and send the change for all leaders. In this technique, the load of the center of the leader, which is located in the center, is placed in the center, is more than other leaders. And the final topology is all-to-all topology. In these techniques, the leader, each two leaders can communicate with each other, and so each change which happen in each one, okay, then the leader need to prepare appropriate message and send the message to all other leaders. For example, something we change in this leader, in the left leader, create appropriate message and send these chains to all three leaders. This is interesting topology, but it's costly because we need communication between each two leaders, and it's costly because of network and links and network connections between them, because we need we need all-to-all topology in the network to change the information between all leaders. Okay, these are three example topology in which multi-leader application can be set up. Which one is the best of these three topology? Each one has its own advantage and its own disadvantage. For example, Mustafa, the all-to-all topology is more costly in comparison with these two topologies, but in this technique, in all-to-all topology, the chains and something which chains can be sent to other leaders quickly, and the time is the delay between the synchronization, between the leader synchronization, is lower than other two topologies. But for example, circular topology is not costly because only we need one link between two leader, but the delay is so high in comparison with other two topologies. And also, when for example, when a connection between these two leaders, for example, when the connection between and these two leaders is cut off, for example, okay, so this is a challenge for this topology. Usually I can say the all-to-all topology is better, but after that the star topology, and after that the circular topology. But it's up to some policies which are decided for the database designer. Okay, Any question? Do you agree, Mustafa, with something that I say? The star topology, Nazar asks, the star topology, where can it be slower because it was get a big load on the master leader? No, no, Mustafa. The circular topology is slower because we know that the master leader is responsible to get, but we know that in this technique only two hop, there are only two hop between these two hop, okay, two hop. Uh, please let me. One hop, two hop, three hop. There are three hop between these two leader. Three hop. But in this technique, between each two leader, there are only two hop. You can increase the number of matching the number of leader from 4 to 10, for example, 10 leader. Still, you can see only two hop between each two leader. But in this technique, when the number of matching is increased from 4 to 10, okay, for two matchings, it's possible that there are 8 hop between these two matches. Okay, Nazar. Mohammed Jafar said the third option is the best since the loop is connected in more than one direction and the cutting in the network does not affect the information. Yes, Mohammed. Yes, thank you for your sentences. Yes, the cutting in the network, the cutting in the network between these two links cannot affect the other leaders. Yes, does not affect the information, and it's also fast. Okay, we can go to the next slide. Okay, in the next slide we can see two client and a client B, and also there are three leaders, leader 1, leader 2, and leader 3. The client wants to insert into data these values x and 1, values x for the key x. The client A wants to insert the value 1 for key x. This insert query is sent to the leader 1, and the leader 1 execute the query and send the OK for the client 1. And also the leader 1 send these queries for the two other leaders, for the leader 3 and for the leader 2. Leader 3 get this value, and after that you can see the client B wants to update the value of the data with key x. The client B wants to increase the value of the X data. Oh, okay, so and this query is sent from the client B to the leader 3, and leader 3 after getting this request, it changed the value from 1 to 2. We know that. Change the value from 1 to 2. And again, the leader 3 should send this change to leader 2 and the leader 1. But in this figure, you can see, unfortunately, the leader 2 first get the change which is sent from the leader 3, and after that it get the change which is happen in the leader 1. Okay, so when the leader 2 get this update query from the leader 3, there is it cannot find the X value, the key X, because you can see the leader 2 wants to update the key X, but there is no key X because the insertion request is received after the update request. So with multi-leader replication, writes may arrive in the wrong order at some replicas. For example, at replica 2 in wrong order. We know at first the leader 2 should receive the change in leader 1, after that in leader 3, but unfortunately the leader 2 first receive the change in leader 3, and okay, so because of the order and the wrong order in receiving because of the wrong order in receiving the change, it cannot do them. To order these events correctly, version vector can be used. Okay, this is one method for this challenge. Okay, that's enough for today. Today I talk about the multi-leader application. Inshallah, in the next session I'm going to talk about the leaderless application. Any question? Thank you for your participant. Thank you for cooperation, and inshallah in this week I will upload some video file in English version about the replication, about something that I say in previous session, and also in the next session I am talking about them, and you can download and watch them. Thank you so much. Have a good day. Have a good week. Bye for now. Inshallah, I as soon as possible I will upload them. You're welcome. Bye for now.